For ideal gas problem, other than solving for more calculation, just like what I said before, they can ask you something about the relationship between pressure and volume and also temperature. So just like this one, if the question wants to increase the volume, then at the same time, then you have to increase the temperature, as these two things are proportional. That means you have to pick a higher temperature first. So must be this one and this one. But then if V and T are proportional, then for P and V are opposite, they're inversely proportional. That means if I want to make a higher volume, then I need a smaller pressure. That's why the only answer will be here and then D. So a basic relationship make sure you can recall is like if the two variables are on the opposite side, like volume and temperature, then they are proportional. Like pressure and temperature, they're also proportional. But then if two numbers are on the same side, then actually they're inversely proportional. That means when volume increase, pressure will be decreased, which is in the opposite direction. Then for second question, then you have to understand the relationship, then you have to do some algebra solving. Because in here, they told you one thing is, if the volume change into 160, but then you can see that pressure no change. That means in the ideal gas equation, then first of all, you can cross out the pressure because there's no change. And also the mole no change because they are not a really reaction. And also R is no change also because the gas constant 8.3 on all the time. That means the only variable will be volume and temperature. And then just like what I said, they are kind of a proportional variable. That means you can setting up an equation like this. For any x and y, if they are proportional, then actually you can write down some of that. And obviously, if they are inversely proportional, that means the product will be a constant. So it will be x1, y1 equal to x2, y2 if everything is inversely proportional. Then based on the proportional relationship, then I can put in a number like this. But the important requirement is in here, temperature, you have to use in Kelvin. Therefore, if you're just using degrees Celsius, you think just, okay, here is like double, then the temperature is also double, then you will pick 254 directly. But then if you are using Kelvin, then you can just double in temperature in degree. So A is kind of a trap in here. Then first of all, you have to change temperature into Kelvin. Then here, it gives you 400 Kelvin. That means the new temperature, after the double in volume, then double in here, then the new temperature should be 800 in Kelvin. But then the question is looking for some temperature in degrees Celsius. So that means 800 degrees is also a kind of trap. So 800 Kelvin, then you have to change back to degrees Celsius. That means it will be 5 to 7 degrees Celsius. So that's why the answer will be C. And then for this question, if you have calculators, then obviously you can do an easy addition and subtraction. But then even you don't have calculator, as you may be studying IB chemistry, then for paper 1 question is like non-cal section, then you can actually see that the number they always will setting up into a nice number. Like the total must give you something 400, 500, 600 Kelvin. And then even you have to do a subtraction, but then you can see the number is so far away. So only 527 will be a reasonable answer if you try to look at the choice for B and C and D. Therefore, even you don't have calculator, they are not really setting up your question to really testing your mental math. More important is still the logical skill, still the relationship between volume and temperature. And especially in here, make sure you're using temperature in Kelvin, which is a really important trap. For pressure and volume, you don't have to really change the unit. But then for temperature, make sure you convert the temperature in Kelvin. Otherwise, you can't do a calculation. The next one will be a really mole calculation question. And then every time when they're looking for volume of gas of something, that means at the first point, you can't find the volume of gas. You can't find the mole of gas also. So every time if the unknown is gas, then you have to find out the mole of something else first. Then obviously you only have one more data, which is like 3.4 gram of barium nitrate. Then based on the mass over molar mass, then at least you can convert the barium nitrate into mole first. Therefore, in here you will have 0.013 mole of barium nitrate. And in the question, they are looking for the gases supported, they're formed in the reaction. That means in here, the answer will be both including oxygen and also NO2. Because based off a formula, obviously we know that the gases formed. So you can see the mole ratio is like 1 to 5. Because you have mole of gas, it's like 5. And only have 1 barium nitrate. That means the mole of gas is like equal to 0.013 times 5, which is like 0.065. Then once you know the mole, then it's time to putting in everything into an ideal gas equation. And then R is 8.31, and it's 0.065, and then temperature you will have 470. And then pressure and volume, just like what I said before, the unit of pressure and volume is not really important, but they just make sure that you're using as a pair. Now for pressure, maybe in this case, I just keep on the unit in the question, therefore I'm using Pascal in here. Then the volume, just make sure you remember that here is like in meter cube. Therefore, after the solving, then we will get a number for volume as in terms of a really small one, which is 2.25 times 10 minus 3. But then here is a meter cube. That means if we want a cm cube, then the condition is like meter cube times 1000 give you dm cube, and then times another 1000 will give you cm cube. Then after I do the conversion, then here will be 2251.3 cm cube. So you think actually this kind of ideal gas equation is also similar to a mole calculation, but then just in the conversion from mole into volume of gas, you have to do a kind of a longer way instead of just using this one, volume over 24 dm cube. Then you may just do one step calculation, then you already get the answer already. So maybe ideal gas just make your algebra become like algebra solving become more and more difficult, but then the concept is not really difficult, and also they're just making you getting more and more confused because you have so many units that you have to change. So here will be another example. Then in the question they told you something about the volume of gases and also the temperature and pressure, and then just what I said before, if you see some random pressure and temperature, that means it's a kind of a hint to ask you to using PV and LT, because you can't using this equation for volume over molar volume give you more anymore under this kind of specific condition, unless they really give you a new molar volume, but then obviously it's not the case in here. Therefore, based on the volume that I can directly put in for 4.5, and then pressure will be 100, and then if here I'm using meter cube, then those one I have to over 1000. I have to times 1000 to change into Pascal. And then here's meter cube. Then R is 0.3 all the time, and then temperature will be 3T, but then adding with 2 and 3. But then if you're using this equation to find the mole, then in this case we have to really be careful about the meaning of the mole, because all those numbers 4.5 and 30 degree and 100 kPa are referring to the gases formed in the reaction. That means the gases formed in the reaction is like involving two different gas. So even you have the mole, but then here is the mole of NO and steam at the same time. But then still, we can do a solving first. Then after you do the solving, then you can find out the mole is like 178.7. So that's all I said before. Here's the total mole of the two gases. So if we want to find one of it only, which is water, which is a steam, then we can just using a mole ratio, because total mole is like 10 gases. That means the mole of water, let's talk about just 6 out of 10. So the ratio, you can just using the total mole here, multiply with the ratio, which is like just what I said, because you only have 6 water, but at the same time the total amount of gas is like 10. That's why the relationship will be like that, 6 over 10. That's why the answer will be this one. So here will be the answer for this question, and then we just end the typical ideal gas equation.